totally lost? I hope I did this right. No, a woman believes there's a 20% chance that she's pregnant. Okay, well, was this too much of a leap? I don't know. It's okay? Are you guys going okay? Did anyone get this number, 0.0025? Good? Okay, good. Alright, let's see. So what do I put here? The woman is
Pregnant or not
pregnant or not pregnant, okay? Okay, and so what's the probability that she's pregnant?
0.2.
0.2. And not pregnant? 0.8. Okay, so yeah, some of you guys wrote 0.5 and 0.5. Okay, that's not the case, right? I mean, if that were the case, then half of the women you see every day would be pregnant. Okay, and our population would boom and very, very quickly. Okay, this probability that a woman is pregnant is different for every person, right? Okay, it's different for every person. So for some women that probability is 0, and for other women that probability, well, if she's pregnant, is 100%. So it's different. But right now, before she takes the test, she's 20% pregnant or 80% not. Okay, so then the test can be positive or negative. Positive or negative. So if she's pregnant, what's the probability of getting positive?
0.99.
0.99, and probability negative? 0.01. And if she's not pregnant, what's the probability that it gets positive?
0.005.
0.005, and probability of negative? 0.995, not 0.95. Okay, there's a huge difference between 0.995 and 0.95. Okay, so if the test comes back negative, what's the probability that she is actually pregnant? Okay, this would be, what's the probability
Actually pregnant.
that she's actually pregnant? Okay, so pregnant and negative test results. Divided by the probability that anybody gets a negative test result. Okay, so what's the probability that a woman is pregnant and gets a negative test result?
0.002.
It's 0.2%, 0.2 probability that she's pregnant, 0.01 probability that she will then get a negative test result. So we get 0.2 times 0.01, and so the top part is 0.002. What's the probability of getting a negative test result? Well, there's pregnant women who get negative test results and non-pregnant women who get negative test results, as they're supposed to get negative test results, right? If you're not pregnant. So there's two ways for this to happen. This is, we have 0.2 times 0.01. These are the pregnant women who get negative test results. And we have the non-pregnant women who get negative test results. So this is 0.002 plus 0.796. Thank you. So I've got 0.002 divided by 0.798. Okay, and rounded off, I get 0.0025 when I do this division here. Yes, question?
So is the assumption of this problem that the woman's belief about her pregnancy status is her actual pregnancy status?
Yes. So this thing that we've done is known as Bayes' rule, okay? And this is where the Bayesian probability of belief comes in. If this woman says, it's impossible for me to be pregnant, right? And you know, somehow she gets a positive test result. If her prior belief is that it's impossible for her to be pregnant, okay? So, how to put this delicately, but okay, but so yeah, okay. Let's say it's impossible for her to be pregnant, but somehow the pregnancy test comes back positive. Then the only possible answer then is the pregnancy test is wrong, and I am not pregnant, right? On the other hand, if a woman says, oh, you know, there's a slight chance that I'm pregnant, and the pregnancy test comes back positive, then suddenly the probability that she's actually pregnant dramatically rises, right? It may not be 100%. It's not going to be 100%, but if the test comes back positive, and there's a slight chance that she's pregnant, then it suddenly, the positive test boosts that to, you know, now there's like a 90-something% chance that she's pregnant. Okay, and so the prior beliefs do play a part, and you know, I guess belief is a kind of a funny word when we're talking about probabilities, but in this case, it's we're going to treat it as the true probability. Is that all right? Okay. So you'll have some exercises in your homework that go over probability trees. Okay. Okay. I gotta get to the next section, which is so a lot of these things that I've written can be written symbolically, okay? So what's the probability, if the test comes back negative, what's the probability that she's actually pregnant? This can be rewritten as probability of pregnant, and I'm going to put a vertical bar saying negative, okay? And this is read as probability of pregnant given negative. Okay. Probability of pregnant given negative. This says given, or if we know someone has a negative test result, what is the probability that they are pregnant? Okay. So the part that you know, the given part comes after the vertical bar, and the part that you're trying to find out comes before the vertical bar. Okay, and so this answer is 0.0025. Is that okay? Let me reverse that. So I know I didn't put it here, but in your notes you should associate this question with this equation here, or this symbolic representation. Okay, so if I show you this, what is the question that corresponds to this symbolic representation?
Probability of
Negative.
Not pregnant.
Okay, so what part is given?
Pregnant.
Pregnant. Okay, so given means that what? We know this is the fact, right? So we say if we know a woman is pregnant, what is the probability that the test result is negative? That's what this represents, okay? So if the woman is pregnant, what is the probability that the test is negative? Test shows negative. Okay, and what's the answer to this question? 0.01. Okay, and that comes from our question, which says, let's say that if she is pregnant, it will report positive with probability 0.99, which means how often will it report negative? 0.01. Alright, you guys are being quiet, so some of you are actively participating, and that's great because I know that you guys understand. But then others of you are being quiet or you're giving me blank stares. So, and maybe it's because you're shy, but and that's okay. So if you're good with this, just nod your head. Okay, well that makes me feel bad. All right. Okay, so the general form, anytime you've got this given probability setup, okay, this is probability of A given B, or basically, if we know B is true, or event B happened or is true, what is the probability of A? That's what this is saying. Okay, the general form of this is what is the probability of A and B divided by the probability of B. Probability of A and B divided by the probability of B. And we saw that, right? When we did probability of being pregnant if you have a negative test result. You can check your notes. We did probability of being pregnant and negative divided by the probability of getting a negative test result. Okay. And it was just that the negative test result had to be split up into the pregnant people who get negative test results and the non-pregnant people who get negative test results. Okay. So sometimes work is involved with this one. Okay. And again, you know, these labels could be flipped around. And so what's the probability of B given A? This is the probability of A and B divided by probability of
A.
A. Okay. And you should note that, probability of B and A is the same thing as probability of A and B. So basically all I did was just flip the position of A and B around, and that's what we get. That's what we get. Alright, let's check, so just a few rules that we've already stated, but maybe, maybe we're already aware of, but maybe I just need to formally state, okay? So for any event, for all events, whatever it is, okay, the probability of that event, A, is some number in between 0 and 1 inclusive, okay? Probability, if probability of A equals 0, it means it never happens. If probability of A equals 1, it always happens, okay? The probability of A not happening so this is wonderful, okay? This is another one. The probability of A not happening is known as the complement of A. So we write A complement, or we just write not A, or something. And this is equal to 1 minus the probability of A. So if there's a 20% chance that A will happen, what's the probability that A will not happen? 80%, okay? 1 minus 20% gives us 80%. So that's the complement, okay? For any experiment, random experiment, okay, the sum of all possible outcomes, or the sum of the probability of all possible outcomes, is what? Is 1, okay? So the probability, if we add up all possible outcomes, they have to add up to 1. Okay? Which is kind of saying, is related to that. If I ask for, let's say we have 2 events. A and B. Right? If I say, what is the probability of A or B, probability of A or B happening, this is equal to the probability of A plus the probability of B minus the probability of A and B. So let's say there's 1,000 people. Okay. Let's say 800 people like ice cream. That should be like 990. But okay, 800 people like ice cream. And let's say 300 people own a dog. Okay. I could ask, what's the probability, if I pick a random person from the crowd, what's the probability that this person likes ice cream? What's your answer? 0.8, okay? And if I say, what's the probability that this random person from the crowd owns a dog?
30.
0.3. Okay. Let's say 270 people like ice cream and own a dog. So I ask, what is the probability that someone likes ice cream? So we're starting a new club, and it's the Cool People Club. If you get in if you like ice cream or you own a dog. Okay, so what's the probability that someone likes ice cream or owns a dog? Okay, and anytime you see an or, it's an and or. Okay, and or. So if you like ice cream and you own a dog, you're still cool. And if you like ice cream but don't own a dog, that's alright. And if you own a dog but don't like ice cream, that's also okay. But if you don't own a dog and you don't like ice cream, we don't like you. So, what's the probability that someone likes ice cream and or owns a dog? Or how many people? How many people like ice cream and own a dog? Or own a dog? Huh? $830. 0.83. This answer is 0.83. Let me show you how. Okay, this is all 1,000 people. There's 1,000 people total. This is everybody who likes ice cream. Okay? And these are people who have dogs. How many people like ice cream and own a dog? 270 out of 1,000. So what's that? That's 0.27, yeah? Okay. So if this entire circle, how much is this entire circle?
300.
300 or 0.3. So how much?
0.03.
0.03 goes over here. Does that make sense? Not your head? Okay. Alright, so then what goes over on this side? Likes ice cream but doesn't have a dog.
0.53.
0.53. Okay? Because this entire circle has to add up to 0.8. Alright, good. So, likes ice cream or owns a dog is this double circle. And if you add that up, so basically this entire circle is 0.8, and then we just have to include this moon part, which is 3%. So I get 0.83. So probability of dog or ice cream, 0.83. Okay. So how many don't like dog? No dog and no ice cream. Boo. 0.17, okay? We might have to draw this thing, but the entire thing adds up to 1,000 or 100%. So if I've got 83 in the double circle, I got 17% not in the double circle, which is this. This is no dog and no ice cream. No dog and no ice cream. Sorry, I know it's a lot. And then one more. What about probability of no dog or no ice cream?
Didn't you say it's and or is the same thing?
Well, and is not an and or.
Okay, but
This is
or
and
is the
or.
and or.
This one, the or is the and or. So probability of no dog and or no ice cream. Okay, well let's look at this thing and what qualifies. What qualifies? All right. So this group out here, the 0.17, these are the people who have no dog and don't like ice cream. Okay, do these people qualify for that? Yes. Okay. These people like ice cream and have no dog. Do they qualify to be part of that group? Yes, because we're asking to qualify for this group, you either have to satisfy no dog and or no ice cream. Okay? So these people, they like ice cream, but they have no dog. So we say, okay, you're cool. Alright, these people, they like ice cream and have a dog.
No.
Do they qualify?
No.
No, they don't qualify. Okay. And these people own a dog but don't like ice cream. Do they qualify?
Yeah.
Yes. Okay. So yes, 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 no. Okay? So if you do all of that, you can do 1 minus 0.27 or this plus this plus this and you get
0.73.
0.73. Shake your head if that was no good. Okay, no one's shaking their head. All right. Let's take a little break. Okay, we'll take a break. We'll come back 9 o'clock and finish.